I am Anil Kumar. Welcome to my YouTube channel. In this video, we'll discuss geometric sequences with Rohan, topper of grade 10. I hope this lesson will help you prepare in advance for geometric sequences. In case you want to learn from me, you can always send an email on the address given and be prepared to be successful in studies. Now let's enjoy the lesson and understand concepts. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So Rohan, today what do you want to learn?
Sir, today I'd like to learn about arithmetic and geometric sequences.
Perfect. So let's begin with last time we did arithmetic sequence, right? So I'll
Yes.
do the introduction of arithmetic sequence and then begin with geometric sequence today. Is it okay?
Okay, sir.
So let me share with you a whiteboard. So we're talking about sequences. Sequences as different terms, and we did see arithmetic sequence. Let me write A as for arithmetic sequence. So it was given by A, where A is the first term plus D. D is the common difference, and each term is D more each time, right? So common difference being added. Is it okay? So this
So would
was
it be general?
the term, and general term was A plus N minus 1 times D, correct? So that is the
Yes, sir.
sequence which we did earlier. So we have a common difference of D. So A is the first term, also written as T1. And then D is common difference. So T2 is actually equal to T1 plus D. Is that okay? And generally, we can write Tn as T of n minus 1 plus D. So that means difference between consecutive terms is D, correct? Correct. So as an example, we could take any example. We'll just take an example as, let's say we have a term 3 and then add 4, we get 7, add 4, 11, add 4, 15, and so on. So that becomes a arithmetic sequence. Is that clear to you? So in
Yes,
which
sir.
A is equals to 3, D is equal to 4, right? 3 plus 4 is 7. And the general term Tn can be written as 3 plus n minus 1 times 4, right? So if you simplify this, you could also write this as, because 4 times is being multiplied, 4n, right? So 3 plus 4n minus 1. And so the general term can also be written as 4n minus 3. Is it okay? So two ways of writing a general term. And that is the summary of arithmetic sequences which we did last time. Correct?
Yeah.
Okay. So let me clear this, and now we'll talk about geometric sequence. So if we have a sequence which is something like this, let's say 2, and then next term is times 3, 6, times 3, 18, like this, right? Times 3, 3 times 8, 24, 54. If we have something like this, it is definitely not an arithmetic sequence because the terms here are increasing by greater and greater number. Correct?
Yes,
However,
sir.
what you figure out here is that the quotient of consecutive terms, 6 by 2 is 3, right? Then 18 by 6 is also 3, and 54 by 18 is also 3. Do you see that?
Yes, sir.
So here we know that the first term T1 is 2 and T2 is basically equals to 2 times 3 and T3 is equal to 2 times 3 times 3, right? And so on. Right? So we say this 3 is constant. So we have a constant ratio. Which will denote by letter R. And the first term, as usual, we'll write A. In that case, we have a sequence which could be written as A times R, AR square, AR cube, and so on, correct? What could be the nth term? AR to the power of, look here, this is my first term, second term, third term, fourth term. So in the nth term, the exponent should be one less than the term number, right? Nth term.
Yeah.
Does that make sense? So any sequence in this fashion will be treated as geometric sequence. If I graph this sequence, how will it look like? At one, let us say it is 2. And then at second term will be kind of like this, like this, like this. So you'll notice that the graph increases exponentially. Do you see this? Very fast. It is based on the previous term, right? So you can
Yeah.
also write a general term Tn as equals to Tn minus 1 times R, right? Because we are multiplying each term, previous term by R to get the next term. Is that clear to you? So that
Yes,
becomes
sir.
a geometric sequence. So make a note of all this.
Wait, so sir, so this would all relate to a constant ratio, right, sir?
Constant ratio. Yes, yes, yes. So let me take some examples of geometric sequence and we'll work on those examples. So here is one. We have a number 625, 1250, 2500. So this, I'm saying this is in geometric sequence, right? Now for this geometric sequence, can you write down the general term?
Like the general term and sense of like a plus in bracket n minus one multiplied by d, sir.
A times R to the power of n minus 1. First, we'll verify whether it is geometric sequence or not, right? So find
Okay.
the ratio of consecutive terms. So the ratio is 1250 divided by 625. What do you get? And also find the ratio 2500 over 1250. What do you get? You get 2 in both the cases.
Two. Yeah.
So that means the constant ratio between the consecutive terms is 2, right? And therefore, it is a geometric sequence where the first term A is 625. And therefore, I can write down the general term Tn as equal to 625. R is 2 to the power of n minus 1, correct?
Yes, sir.
Can you write down a recursive formula for this? Recursive formula relates to the previous term, right? So we could write that T1 is equal to 625, right? And Tn is equals to T of n minus 1 times 2, right? Times 2. Or 2 times Tn minus 1. Is that clear to you? We just double the previous number to get the next number, right?
So, sir, the recursive formula would be like T of n is equal to T of n minus 1 times R.
2, right, R. Correct. Yeah, so in general, recursive formula will be Tn will be R times Tn minus 1. Correct. So let's find the general formula for a few more examples. Let me take up more examples, right? Let's say example number 1 for you is 6, 2, 2 by 3, and so on. So for this, can you find what is Tn?
Wait, sir, so it's 6 to 2/3, and we have to find the recursive formula, sir?
Right.
Okay.
Correct? So every number is 1/3 of the previous number. Let's take one more example. 1, 0.2. So in this case, what is A equals to? 1. What is R equals to? 0
1 divided.
by 1, which is 0.2, right?
Yeah.
So let's check the other two terms also. 0.04 divided by 0.2. What do you get?
0.2.
0.2. And therefore, you can write the nth term as 1 time 0.2 to the power of n minus 1, which is 0.2 is 1.1 over 5, right? 1/5, correct?
Yes.
So you could also write this as 1/5 of this, right? So if T1 is equal to 1, then Tn plus 1 will be, sorry, you can write Tn. Nth term will be 1 times 0.2, right? 0.2 times Tn minus 1. You can also write this as 1/5, right? Is that clear to you?
Sir, how do we get a T of n is equal to 1/5 T minus 1?
Okay, so if I write 0.2, 0.2 is equals to 2 over 10, right? which is 1 over 5. Correct?
Okay, sir.
Let me take another example. So from my notes, I'm taking some examples which are going to help you. So let's say we have a geometric sequence where the fifth term is 45 and the eighth term is 360. You have to find the 20th term. Try to do this example. So with the two given terms, you can get the two equations. T5, fifth term is 45, which is a r to the power of 4 n minus 1, right? T8 is 360, which is equal to a r to the power of 7. Now, how will you find a and r from these two equations? Tell me.
Would we sub in equation? Would we?
We divide.
We divide it.
Yeah, divide equation 2 by 1, a cancel, right?
Yeah.
So you get from here you get 360 divided by 45 equals to r to the power of 7 divided by r to the power of 4, right? So you can actually get r cubed as equal to divided by 45, which is
72. And then square root 72.
From the 4th of December. So from 4th of December to the 12th of December.
so we have 45 equals to a times r to the power of 4. So 45 equals to a times 2 to the power of 4. So a equals to 45 divided by 2 to the power of 4. Correct? Which is 16, right? Now from here we can find T20. T20 is 45 over 16 times R, which is 2 to the power of 19. Sixteen, 4 minus, right, 15. 45 into 2 to the power 15, right?
Sir, I got a TF20 is equal to 1,474,560.
It could be, yeah. Yeah, it could be, yeah.
Oh.
2 to the power 15 is a very big number. Correct? So we could write this in exponential form also. You're right.
Wait, sir. So I did like the same way as you. It's just that how did you get 45 divided by 16 multiplied by 2 to the power of 19 to 45 multiplied by 2 to the power of 15.
16 is 2 to the power of 4, right?
Yeah. Did you just subtract it by 4?
Yeah. So 40 to the power of 19 minus 4. Correct? So you have understood geometric sequence, right?
Yeah.
Now I'll talk about another very important concept. We know arithmetic sequence and geometric sequence, right? Now today we'll talk about arithmetic mean and geometric mean. So in general, arithmetic sequence is A plus D, A plus 2D, and so on, right? And the geometric sequence, this is arithmetic sequence. A, AR, AR square, and so on. This is geometric sequence, correct? So if we take 3 consecutive terms, let us say, then how are they related? How is the term A plus D, and A plus 2D related? So you'll notice that if you add these two and then divide by 2, you get the center number. So you can say A plus 2D. If I divide them by 2, it is like average of the two, mean of these two numbers is you see that? So arithmetic mean, basically there are 3 terms, Tn minus 1, Tn, and Tn plus 1. If you take 3 terms, in that case, you will notice that Tn is equal to Tn minus 1 plus Tn plus 1 divided by 2.
Okay, sir. My only question is that for A plus in brackets A plus 2D over 2, how do you get to A plus 2D? Wouldn't it be 2A plus 2AD plus 2D?
Divide by 2 will give you A plus D, which is your center term, right?
Oh.
You get the idea? So any arithmetic sequence, the center term is the average of the two on the sides. For example, if I have a sequence, 7, let's say 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16, and then plus 3 is 19, correct? So how is 10 related with these two numbers? 7 plus 13 divided by 2. Do you see that? Is
20 divided by 2 is 10.
Correct? 7 plus
Yeah.
20 divided by 2 is 10, correct?
Yeah.
Similar, you could also work out these, add these two and divide by 2. So 13 plus 19 divided by 2 is 32 divided by 2, which is 16, correct?
Yep.
So what you notice here is that the center term is average of the two on its side whenever you're talking about arithmetic. You see that idea?
Yeah.
So in general, in arithmetic sequence, the arithmetic mean is the average of the two on the side, right? One below, one above. So the term mean is add them divided by 2. Is this concept clear to you?
Yes, sir.
Now let's talk about the geometric sequence. In general, geometric sequence is AR, AR squared, AR cubed, AR to the power of n minus 1, and so on, right? Now, what is the mean of these two? I mean, how do you relate AR with the other two? So you'll find, I'll write down what geometric mean is, then it will make more sense. So if I do A times AR squared and divide and find the square root, what do I get? So you see, when I multiply them, product, in that case, it is square of the middle term, right?
Yes, sir.
The square root of the product of terms on the side is the geometric mean, right? So my three terms are, in that case, Tn is equal to square root of Tn minus 1 times Tn plus 1. That is the geometric mean.
So basically, instead of dividing, we're doing multiplication and square root, right, sir?
Yes. So it's a very important concept, and many times we use the term geometric mean. Find the geometric mean when we give you the term, let's say 6 and 8. The geometric mean will be T7 in between.
So, like, what would be an example that it would be used? Like the 2 multiplication, say? Like, if it's starting at 2, 2 times 2 is 4, 2 times 4, 8, then so on and so forth. 8 times 2, 16.
Yeah, so if you have, let us say, 3 terms, let's say you have, let's say we have a term 10 here and another term, let's say 20. And in between, let us say 10 and 20 are 2 different terms, but they are in arithmetic sequence. Right? So let's say this is like one term, this is in between, there's another term. So what is the arithmetic mean of these two? Arithmetic mean is 15, right?
Yeah.
And what is the geometric mean of this? 10 times 220
divided by. So square root of 200.
Yeah.
Which is 14.14.
So sometimes we use this in this fashion, square root of this. So arithmetic mean and geometric mean are used in many times when we have some word problems. They can give you that these numbers are related as this is arithmetic mean and that is geometric mean.
Okay. So for the term, right? when we're doing geometric mean, right? Is it okay if we leave our answer instead of like finding out the square root? So for an example, this like 10 times 20 square root, right? Is it okay if we just left it as instead of 14.14 as square root of 200 or no?
10 square root 2. Because 200 can be written as 100 times 2 and 100 square root is 10. So it is good to write 10 square root.
Square root 2, okay.
Okay?
Yes, sir.
Okay. So that with that we come to an end of this particular session on geometric mean. So can you summarize our today's learning on geometric sequence?
So far, in today's lesson, we took a summary of what arithmetic sequences are, like from looking at their recursive formula and general formula.
Yeah.
And then we took a deep dive into the geometric sequences, learning about the constant ratio and the new general formula as a times r to the power of n minus 1,
Correct.
and recursive formula as t of n equals to t n minus 1 multiplied by r.
Correct.
And then along with that, we went into knowing about what arithmetic mean and geometric means are,
Correct.
and how in arithmetic mean, in order to find whatever's in the middle, is just adding and dividing by 2, while in geometric mean, it's about multiplying and square rooting your answer.
Perfect. We'll take examples based on arithmetic geometric mean and their applications in the next class. And then we'll also continue with the arithmetic and geometric series now. Is that okay?
Okay, sir.
Okay then. All the best.
You too. Goodbye, sir.